Good morning and welcome to another video lesson, guys. Hope you had a good day yesterday, still stuck in quarantine like everyone else. Today we have a lesson and I'm actually doing an early morning edition. Early morning edition, 6:30 a.m. My kids are still sleeping, so hopefully they do not wake up amidst all this. If they do, I'm going to pause it. You might hear them in the background, but you got to do what you got to do, right? So anyways, what are we doing today? So today we're going to do applications of trigonometric ratios. So the notes for these you guys do not have. These are one of the notes I told you did not have. And then also yesterday I had some people text me and say, well, Mrs. Pewd, I didn't get those notes from yesterday either. So some of the notes you guys have for these, you will not for the upcoming lessons. You're just going to have the homework assignment. So you can take notes on a blank sheet of paper then if you want. Or you can just watch the video and then just do the homework. Completely up to you. So when it comes to the prior knowledge, we're going to write an equation to find x using sine, cosine, or tangent. And then we are going to obviously find x and round to the nearest tenth. So step one, you're setting up the trig function. Step two, you're solving it. So if you need to, go ahead and pause the video and do it. Okay, so looking at this problem, by now you should definitely be able to look at a triangle and say, oh, this is sine, this is cosine, this is tangent, with all the practice we've had. So this, by far, I don't have to do any labeling. I know it's going to be a cosine. So I have the cosine of 15 degrees is equal to the adjacent side over the hypotenuse. So I'm going to have to multiply x to each side, and then I'm going to have x times the cosine of 15 is equal to 80. I know this is considered to be a package deal, this cosine 15, so I'm going to have to divide it to each side. Cross cancel. And then 80 divided by the cosine of 15. So if I go into Desmos, which is right up here, 80 divided by the cosine of 15 is going to give me 82.8. Yeah, there we go. So 82.8. So that would be the length of the hypotenuse, which makes sense based on this picture because your base leg is 80 so far, and then 82 looks like it's a little bit longer, and it's let's see, it's a right triangle. So everything looks like it should work out pretty well. Okay, so also I did post the answers to the homework assignments for the last couple days. I just put all the answers up there because it's just really going to be answering some of the questions that you guys have been texting me about. Because some people have specific questions on like number 4, number 5. And then last night's homework was a lot of the word problems when it came to most of the homework, aside from the first 2 that you're seeing. The last 2 were, I think, were a little bit more challenging, and so I posted the answers up there so you can you guys can go back and kind of check and see how you're doing on things. All right. So application of trigonometric ratios. That's what we're going to be doing today. So we're going to be doing more word problems, but the word problems are going to be a little bit more difficult because I'm only going to be giving you the verbal description of what the side lengths are going to be. So David is attempting to fight Goliath. David is knocked down to the ground, but spots a nearby rock he can throw at Goliath's head. If David is 12 feet from Goliath's feet, and David is laying at a 55-degree angle with the ground, how far must he throw the rock to hit him in the head? Sounds like a very brutal word problem, but it works, right? So go ahead and pause the video and see if you guys can actually come up with where the dimensions would be. Okay, so David is attempting to fight Goliath. David is knocked down to the ground. So this is poor David down here. There's David. So he stops and let's see, he spots a nearby rock. So if David is 12 feet from Goliath's feet, so 12 feet would go right here, and he's laying down a 55-degree angle with the ground, that means your angle of elevation is going to be 55 degrees. There we go. How far must he throw the rock to hit him in the head? So in other words, you're looking for the hypotenuse. So based on the overall picture that I have right here, this is going to be a cosine. So the cosine of 55 degrees is equal to the adjacent side over the hypotenuse. So I'm going to kind of fast forward because by now you guys should be able to almost like kind of do a lot of shortcuts, I guess I should say, when it comes to solving some of these problems. So I already know that I would be doing the value of x is going to be equal to 12 divided by the cosine of 55. If you need to show all the work, you can, but because we've had so much practice with this, you probably shouldn't. So if I do 12 divided by the cosine of 55, it's pretty nice. I can just edit this. Okay, I have 20.9. So 20.9, and we are working with feet. Okay, so to save time on today's lesson, I'm not going to be writing out the sentence conclusion, but just know that you do have to write a sentence conclusion for this one. So, how far must he throw the rock to hit his head? David must throw the rock about 20.9 feet to hit Goliath in the head. Okay, so here is another you do. So go ahead and see if you guys can figure out where their dimensions are going to go. So if you need to, pause the video and read everything by yourself. Okay, a mouse is scurrying from a cat late at night. So here's your little mouse up here. Little mouse with little ears. Ugly mouse, but we're just going to say that's a mouse. So a mouse is resting at the top of a 12-foot tall lamppost. So there's the 12. But sees the cat is approaching. If the mouse peers down at an angle of 56 degrees with the cat, then how far is the cat from the lamppost base? Okay, so you might think, does a 56 go there or does it not? So I'm going to have you think, should I put the 56 here or should I move it somewhere? Okay, so the 56 is actually not going to go right here. It's going to be your angle of depression. So yes, the cat is, or the mouse is peering down. Need the eraser. There we go. Yes, the mouse is peering down, but you're basically given an angle of depression. So this angle right here, that one is going to be 56 degrees. That's your angle of depression. So if you're going to be trying to figure out this angle right here, that's when you have to do 90 minus 56. So this angle is going to be 90 degrees minus 56 degrees. And that's going to give you 34. Okay, so I have 34 degrees, and then I think, do I do sine, cosine, or tangent? This is definitely a tangent. So you can say the tangent of 34 degrees is equal to the adjacent side over the, the opposite side over the adjacent side. And then I know to figure out the value of x, I'm going to go ahead and do 12 times the tangent of 34. So 12 times the tangent of 34. Okay, gives us about 8.1, let's say. So 8.1, and then we are working in feet. Okay, so again, for the sake of time, I'm not going to write out the sentence, but how far is the cat from the lamppost base? So the cat is about 8.1 feet from the lamppost base. Okay, so a shelf extends perpendicularly 7 inches from a wall. So the 7 is right here. So what you're seeing is if you're thinking about a shelf, so this is like the wall of someone's house. Everyone has like their little couches set up. You have your little tables with like little flowers on them. So you have a shelf. So this is what the shelf is. So the shelf is like right here. And so this is looking at the shelf just head on, like me looking at it right here. And then this is looking at the shelf kind of on its side. So the braces are what's holding the shelf up, and then this is what you're putting on the shelf. So like if you have a little box right here, or you have something. So this is actually the shelf itself, just so you know, because it's hard to kind of visualize something sometimes. Okay. So the shelf extends perpendicularly 7 inches from a wall. So there's the shelf. You want to place a 9-inch brace under this shelf. To the nearest tenth of an inch, how far below the shelf will the brace be attached to the wall? So what I'd like you to do is think, well, does the 9 go for the length of the hypotenuse, or does the 9 go for the leg of the leg of the right triangle? So think about that. Okay, so when it comes to the 9 inches, the 9 inches is definitely going to be your hypotenuse. Why is that? Because if this is your brace that's holding the shelf up right here, you're trying to figure out how far it's going to be attached to the wall, so you're trying to figure out this distance right here. So you might think to yourself and be like, oh, Mrs. Pewitt, I don't have any angles. There's no angles. There's no 32 degrees, no 15 degrees. I don't know where to start. Well, just stop and think about it. Before we've done any problems with trigonometry, what did we do before? Pythagorean theorem. Boom. So Pythagorean theorem still finds its place in these problems. So you don't want to forget about that because we use it all the time. Okay? So I know I'm going to use a squared plus b squared equals c squared. So when it comes to a and the b, those are your two legs. So one of them will be x squared, the other will be a 7 squared, and then the c is going to be your hypotenuse. So if I start simplifying things, I have x squared plus 49 equals 81, and then I have to subtract the 49 to each side. Okay, and if I take the square root of x squared, I already did the math already side. So the x is going to be about 5.7 feet. Okay, so this is actually a two-part problem. So to the nearest tenth of an inch, so 5.7, how far below the shelf will the brace be attached to the wall? So the brace will be this angle right up here. Okay, so why that angle? Because you're looking at the angle the brace is making with the shelf. So that's what you're specifically looking for. Okay, so that being said, you need to be using cosine. So I can do the cosine of my angle x, or angle A, whichever you want to call it, is going to be equal to 7/9. So you might say, well, Mrs. Pewitt, why are you using cosine? Like, I know this side is 5.7. Can I use a sine? Can I also use a tangent? And the answer is yes. There's a lot of different ways that you can approach the problem. So the reason that I use cosine is because let's say that I made a mistake in my previous work. So let's say that instead of subtracting the 49, I actually added the 49, and I got this answer incorrect. So if I got this answer incorrect, then this answer is incorrect if I try to use it again. So that's why I'm just using my given measurements of 7 and 9. That's how I'm going to go ahead and calculating things. Okay, so if I do the inverse cosine of 7 divided by 9, that's going to give me about 39 degrees. Let me see. So the inverse cosine, just to double check, the inverse cosine of 7 divided by 9. So 38, yeah, about 39. So we're going to say 38.9 degrees. Okay, so what angle will the brace make with the shelf? So the angle will make a 38.9 degree angle with the shelf. That's how you'd say that as a sentence. Okay, so for this next problem, I'm going to go ahead and pause the video so you guys can do it, and then I'll do it on my end. Hi guys, and welcome back. So a building casts a 33 meters shadow when the sun is at an angle of 27 degrees with the vertical. So in other words, this is 27 degrees up here. I'll do this in yellow. This is 27 degrees up here, and you're trying to figure out how tall the building is to the nearest meter. So the building is located right here. I got about 64.8 feet. If I'm going to round it to the nearest meter, so I have to pay attention to the directions here. If I'm rounding that to the nearest meter, that's going to round up to about 65 feet approximately. Because again, I'm rounding to the nearest meter. So what angle does a ray from the sun along the edge of a shadow make with the ground? So in other words, you're looking for the angle of elevation on the second part of the problem. So if you use the inverse tangent of 64.8 divided by 33, you're going to get about 63 degrees. So before, on the previous problem when it came to the shelf, I said try not to use that side length. Well, sometimes you don't really have a choice. You have to use that. So if you made a mistake here, it does kind of follow you through here. So I got about 63. If I were to put 65 in instead of 64.8, let's see how much it changes the answer. Okay, so about 63.0, which you're still going to get about the same thing. So it doesn't matter if you use 65 or 64.8, you're still going to get about 63 degrees for the angle of elevation. Okay, so for this one, there is no triangle, nothing, diddly. So first thing I want to do is just kind of draw a triangle to what I think would best represent the problem. And this is fun because you get to exercise your drawing skills. I know some of you guys are artists, like Evelyn. All you do is draw, sister. Do a lot of drawing. So this should be a lot of fun for you. So a bird is laying in a nest at the top of a tree. The bird is looking down at a worm at an angle of 56 degrees. If the worm is located 30 feet from the tree's base, how tall is the tree? Round to the nearest tenth. So a bird is laying in a nest at the top of a tree. So please do not criticize my skills, but here's my little nest right here. And then here we got a bird. Got a little beak. Aw, there's a cute little bird. Okay, so we got a bird that's laying in the nest at the top of a tree. The bird is looking down at a worm. Here's a little worm. At an angle of 56 degrees. So that means it's talking about an angle of depression. So 56 degrees is my angle of depression. If the worm is located 30 feet from the tree's base, so 30 is going to be your base length, how tall is the tree? Okay, so in other words, you need to figure out what this angle is going to be, and then you can apply. So if you want to, pause the video and see how much of this you guys can get done. Okay, so I know this angle is going to be 34 degrees. So why 34? Because you have to subtract 90 and 56, because that's going to be your angle of depression, the 56 degrees, to get the 34 that you need. Okay, so I'm going to go ahead and use tangent. So I'd say the tangent of 34 degrees is equal to 30 over x, because it's the opposite over the adjacent. So I know that x is going to be equal to about, let's see here, 30 divided by the tangent of 34. So 30 divided by the tangent of 34, I got 44.5 feet. So how tall is the tree? So the tree is about 44.5 feet tall. Seem pretty easy? Okay, so this one's going to be, I'm going to pause the video, do it. I'm going to have you guys do the same. Oh, again. So you should get about 70.2 degrees. So you're looking for the angle of elevation. You're told that your building is 10 feet tall, and the base of the ladder is supposed to be about 3.6 feet from the base of the wall. Notice that my picture is definitely not drawn to scale. 3.6 definitely looks like it's larger than 10, but this concept is there. So you should get about 70.2 degrees. Okay, so this is another you do, so I'm going to go ahead and pause the video and see if you guys can do it. Okay, so this one is a little bit more complicated to kind of interpret what it means in terms of what the picture looks like, but I tried to draw a rough sketch. After you're able to get the picture, it should be easy. In order to meet the safety guidelines of a roof contractor determines that she must place the base of her ladder 6 feet away from the house. So there's the house right here, and then there's the 6 feet. There's the ladder. So making an angle of 76 degrees with the ground. So the angle of elevation is 76 degrees. To the nearest tenth of a foot, how far above the ground is the edge of the roof? So your roof is obviously what's on top of your house. So we're going to assume it's a very rough sketch of what a roof looks like, but basically you're looking for how tall your house is. That's just another way of wording it. So we're going to say that's about 24.1 feet after you've done the tangent. Okay? Okay, so 2 last examples, and then we have a closure. So Charla, what a name. Charla's bedroom is directly under the roof of her house. So here's the roof of her house, and there's good old Charla in here. Let's draw Charla. There we go. So given the dimensions shown, how high is the ceiling at its highest point from the base to the nearest tenth of a foot? Given the dimensions shown, how high is the ceiling at its highest point from the base? Oh, so that's what we're looking for. Okay, so go ahead and pause the video and see if you guys can kind of figure out what do you think we'd need to do here. Okay, so jumping in, so you're looking for basically what this whole dimension is right here. So I put X, but if you think about it, this part of her room, so in other words, her room is extending from the base right here to 5.5 feet. So I know 5.5 has to go here. So I'm looking for X, which means I'm looking for what it is from basically A to B. I'm looking for that dimension. So if I can figure that out, what this distance is going to be, I can add it to 5.5, and that's going to tell me the whole thing. Okay? So first off, if this is, put a little X right here just so it's closer to the picture. So you have 10.6, you have 22 degrees. So it looks like we're going to be using, let's see, a sine. So you can do the sine of angle 22 is equal to X over 10.6. So to figure out the value of X, it's going to be 10.6 times the sine of 22, which is about, let's see what I get for that one. I got about 4. Yeah, so it's going to be about 4. Let me just go back and double check that. So 10.6. Yeah, so we're going to say that's about 4 because it's going to round everything up. Okay, so if I know this distance right here is going to be 4 feet, so if this is 4, put 4.0 because I rounded it. So this is 4, that's 5.5. You're just going to add them together to figure out what that distance is going to be. So the total distance from basically the base into the very tip of your tip of the roof, if you want to consider it that way, or the tip of the ceiling, is going to be the estimated 4.0 plus 5.5, which is going to be about 9.5 feet. Okay, so how high is the ceiling at its highest point from the base? So the ceiling is about 9.5 feet from the base at its highest point. Okay, so it's going to be a you do. Go ahead and pause the video. I will pause it as well, and we will check back here soon. So the ladder on top of a tree is fully extended to reach the roof of a burning building that is 50 feet tall. So the 50 is representing the entire length of the building, or basically how tall the building is. So how long is the ladder? So you're given that the fire truck is about 10 feet tall. So if the fire truck is about 10 feet tall, you have a 50-foot tall building, the difference is going to be 40. So that's why I got the 40 right here, and hopefully you did as well. So with keeping that in mind, this is going to be sine. So the sine of 65 is equal to 40 over x, and after it's all said and done, you're going to get about 44.1. So how long is the ladder? So the ladder is about 44.1 feet. Okay, closure time. A client wants to build a ramp that carries people to a height of 1.4 meters, as shown in the diagram. What additional information is necessary to identify the measure of angle A? So go ahead and pause and think about this one for a second. Okay, so there's a couple different ways you can look at the problem. So there's one way is you can figure out, let's say you wanted to use sine. So if I wanted to use sine to figure out angle A, I know how tall it is. So in other words, you know the height of basically what the ramp incline is going to be. And then you're also, what you would need to know is you need to know how long the ramp is. So that's one thing. The other thing you could do is, let's say that you wanted to use tangent. So if I wanted to use tangent, I'd use my 1.4, and then I would need to know this value down here. So the other additional information I'd need is, otherwise, instead of having to know how long the ramp is, you could say how far is that specific edge of the ramp from the actual height of the object it's being placed against. So that's another thing. So there's two possible options for this one. Okay, so that's our video, guys. All done, and hopefully you have an amazing weekend. Try to go outside for at least a little bit. I know we're all supposed to practice social distancing, but go take a walk with the dog, go do something, as long as you're 6 feet away from people. You don't want to get that corona, guys. Okay, so have a wonderful weekend. Homework assignment, I will post that, and then I'll also post a little quiz. All right, so see you guys later. Love you.